Let's start with this question. During both boiling and evaporation, liquid water is converted into water vapor. The rate at which the mass of boiling water decreases depends only on the rate at which the water is gaining thermal energy. The specific latent heat of vaporization of water is 2.3 into 10 to the power of 6 joule per kilogram. Thermal energy is supplied to boiling water at a rate of 460 watt. Calculate the mass of water that is boiled away in 180 seconds. Now, we know that the amount of energy required to change the state is given by the formula Q equals M times L, where M is the mass, Q is the amount of energy supplied, L is the latent heat. Here, mass is supposed to be found out, latent heat is given, Q is not given, but Q is given indirectly in terms of power and time. Energy, power, and time are related by the formula Q over T is equal to power, or Q equals power times time. So when written in terms of mass, you get mass M is equal to power times time divided by specific heat capacity. We can substitute the values as 460 times 180 divided by 2.3 times 10 to the power of 6. Simplifying, we get the answer as approximately 0.036 kilogram. The rate at which the mass is evaporating water water decreases depends on other factors. State two of these factors. The two of these factors or any two other factors that the rate of evaporation depends on is the amount or the surface area that is exposed to evaporation, and also the humidity of air that is surrounding, or humidity in the surrounding environment. State two other ways in which evaporation is different from boiling. Evaporation is different from boiling in the sense that boiling happens at a particular temperature, whereas evaporation can occur at any temperature. And also, evaporation occurs only at the surface, whereas boiling occurs throughout the layers of the liquid. Only at the surface.